So I want to welcome you all to our March Think-a-Thon. And I'm actually really excited about this because now we are a year old and we've been doing these and somewhat got them more efficient. So we're happy that we've learned from many of the things that you've contributed to us through the polls that you take and your interest areas as we move forward. We're kind of excited too because we're next month we'll be launching the research examples and actually doing some research projects itself on the Think-a-Thon. So this meeting also is to sort of prep for that for next month as well. I'm Deborah Duran, and the other face you see on there is Luca Calzoni, and we will be running and presenting at the Think-a-Thon today. So ScHARe needs to thank all of these people for making all of this possible. And we really do take the poll seriously about where your level of expertise is, where your interests are. So I'm going to turn this over to Mark, and he's going to explain to you how to do Slido. And then we ask that you fill out these. Actually, Mark, we're going to do both polls, the experience one and the expertise one, because these polls, and so I'm asking you to just sign on to Slido because as we go through the presentation, Luca is going to also ask you to do some Slido things. So if you can please log on to Slido, and they're going to put it in the chat. Mark is going to explain it to you, and they're going to give you a little picture icon for your phone. Mark?
Yes, thanks, Dr. Duran. So as Dr. Duran mentioned, please join us in Slido. You can use the QR code that you see on the screen. You can also go to slido.com or your Slido app on any phone or tablet, and you're going to enter code ScHARE. It's not case sensitive. So the first poll we have is just an experience poll. Tell us a little bit, please, about your experience with Python and R, and we'll display the answers on screen as people respond.
It's also in the chat, so you can just click on the link in the chat.
There's 7 total questions for everyone, so please respond to all of them, and we'll take a look at your responses.
Well, one of the optimistic things that I see is that we're getting an increase of people who have some Python experience. Can you go through the other questions, Mark, please?
Absolutely.
We have some R.
You may just keep cycling.
Yes, please. Good. Part of the reasons that we also show this is to also, we are really trying to do these Think-a-Thons for novice users, people that aren't experts, people that are beginning, who are just learning. And it's nice to see that you're not alone if you're not proficient. So this is good. Can you go to the next survey, please, Mark?
To the interest poll?
Yeah. please check which ones that you are interested in. You can check all that apply. So we are really targeting both the health disparities, health outcome, healthcare delivery researcher, as well as the data scientist who is interested in conducting research using AI. So please help us by clicking on the interest, because we're going to start forming the research interest groups based upon these expertise. So it helps us to track this and monitor it. And again, we ask that you please sign on to Slido so you can participate in the other things that Luke is going to be presenting and doing a little bit later on in the presentation today. All right, so let's move on. I'm going to take the screen back. Are we good? Can we see it, Luca?
We see it.
Okay. So let's talk about what is ScHARe. So as you see in our background, this is a cloud platform. We developed this cloud platform because we really focus on the population science, the social science, social determinants of health types of data. And we want to really focus on health disparities, healthcare delivery research, or health outcomes research. We developed this because it fills 4 critical gaps. We want to increase women and underrepresented populations in data science. These are oftentimes racial ethnic minorities and people with health disparity characteristics as well. So rural, low SES, disability. So we're trying to increase the representation. We also are trying to do a paradigm shift in how we do health disparities research. Pretty much every discipline, especially in basic science and genomics, is using big data. And what we're learning is that we're learning more than we ever thought we would learn because of the amount of data that is being utilized. And it's revealing to us things that we never thought were possible. So we need to do the same thing for health disparities research. Of course, we are always interested and really fight to keep ethical AI at the forefront and do research that mitigates biases. Biases are not a bad thing. They're going to always exist. We just have to pay attention to them and mitigate them and make sure that we address them before we do harm. And the other most important thing that we're trying to do is to provide this resource, the ScHARe Cloud platform, for community colleges, low resource minority serving institutions, and any other agency, community-based organization that doesn't have the money to do cloud computing, access big data, or store their data in any other place. So this is a resource for you all. We use a Terra platform a Terra interface on a Google platform. This is why when you register for ScHARe online, you have to use a Gmail account. The reason that we did Terra was because it also links to the other basic science clouds at NIH, and it allows us to go across the clouds much easier because we have the same infrastructure. And one of the points that we made during the tutorials for many of you who participated with us, and those of you who did not, and I saw in the poll that there was little knowledge about the Terra platform, and I'm going to ask Mark to put it in the chat. Please go to our NIMHD webpage where the tutorials from the past Think-a-Thons have been, and it will also teach you how to do Terra because it's very important. And once you learn it on ScHARe, you can do it on Anvil, Biodata Catalyst, all of us. ScHARe is made up of many components. It has, even though it's a cloud, it has secure workspaces. That's what Terra provides. We have a host of federated data sets. That means public national data sets with no PII. We also are developing a data repository, which should go live by fall. And this is also to comply with the data sharing policy at NIH because the data has to be publicly available. One of the unique features of the repository that we are building, and we're doing it in this way so that we can increase the data interoperability among and between health disparity types of research so that we can get a better picture of the scope of contributors, intervention points, anything dealing with health disparities. In this unique approach that we're taking, we are focused on common data elements, and these common data elements have a uniform defined definition with standardized codes. These codes allow us to do what we call a uniform resource identifier, and it allows us to have better data interoperability. There are over 240 public data sets, mostly focusing on population science, social determinants of health, and behavioral. And yes, there are environmental as well. The data sets are arranged by the social determinants of health categories: economic, education, healthcare access, neighborhood and built environment, social and community context. Plus, we have the health behaviors and some data on disease and conditions. There's not a lot of data on the disease and conditions because we hope to link to other data sets, and we don't need to put everything here when we can link and bring it in. This is just an example of some of the data sets that are hosted. I just want to go over briefly the Terra interface. This is a screenshot from it. And on here, there are secure workspaces. These secure workspaces allow you to decide if you want collaborators to see your research project. It is very secure. Nobody can get into it unless you allow them. So this very safe workspace is where you can actually do all of the analysis and work that you need to do. And you can invite people to come in to collaborate, and you can move them out, kind of like defriending. There's also on the data tab, it shows you what the data sets are and how to get at the data sets. This is a screenshot of some of the way it looks and some of the data sets. Some of the data sets we also have up to 10 years in there, so you can do longitudinal looks at the data as well. In these secure workspaces, as you can see, this is the way that you assign whether you want people to read, to write. It's all up to you. The other really key feature that we've done is we've developed these notebooks, and in these notebooks, there are tutorials. So if you opened a notebook, you basically could just cut and paste code and not even know what the code is going to do or how to write the code in order to run analysis. So we have that kind of information both in Python and in R. And we are also working on adding SAS, which is a statistical program, into the Terra platform as well. So you don't have to know Python and R, you can just use statistics. And Luca's going to go over some of that today because some of the Python libraries will enable you to do statistics. And so for those of you who don't know Python, it would be important to know where those libraries are so that you can just use those statistical codes. We are unique in that our data repository, and we actually are the first institute with NINR, the National Institute of Nursing, to develop common data elements. We've done a Think-a-Thon on common data elements. And what common data elements are, they're variables that are defined and coded and used across studies. The reason that is so important is because it allows us to aggregate data no matter where the study came from. And we're also coding those CDEs to federated data sets like the American Community Survey and BRFIS, because we're trying to develop better data integration and data interoperability. This is just an example of how all of that works, and it allows us to do that because of the common data elements. These are the labels for the common data elements. Of course, for each of these, it is a question and an answer. And a common data element basically says that the question and the answer is asked in the same way across the studies. For those of you who are already doing research, you can go to this CDE repository at this link. These slides will be posted, so you don't have to write it down. And you can download all of these CDs now because they're in this library. They're NIH endorsed, which is a very high status of recognition, and they are ready to be used. So we're doing this Think-a-Thon as you have joined us, and so you kind of know what they are. All the Think-a-Thons that we've done in the past have been tutorials, instructional, how to do things. We are now moving into, by the way, these are the ones that we've done. For those of you that are brand new, these are all posted on the Think-a-Thon website. I'm sure Mark has put that in the chat, and there's the link up here at the top of the screen. And you can go there and look at the videos and the PowerPoints that were produced for those Think-a-Thons. So what we're going to do now, this is what it looks like on the posting. So this is how they're posted. Over here, you can see on the past Think-a-Thons, you have the PDF, and you can also look at the video. What is coming up is the research Think-a-Thons, and we're going to be preparing for these now. And much of what we're going to do today is going to focus on that preparation for the research Think-a-Thon. And basically what's going to happen is that we hope that there's a cross-discipline, and we say this all the time, that it's important that there's diversity, both in career and discipline, so that there is a generational exchange of information. And it won't matter if you're a junior investigator or a senior investigator. We all have something to teach each other. And that's what these research teams are designed for. So in the research Think-a-Thon, we're going to launch 4 of them initially. And we've have selected and asked co-leads to do these. And as Luca goes through, much of this will make more sense. I think one thing that is really important for me is this project expectations. These are going to have a limit of approximately 3 months because I don't want things to prolong. This is really a way to help people learn how to do many of the things that we've talked about: data dictionaries, data sheets, draft a publication. These are all things that we can help each other learn to do. We did that poll. So I'm going to turn it over to Luca now, and he's going to go a little more in depth, and we're going to end the Think-a-Thon today brainstorming about research ideas. So I hope you all stay on, and contribute to that brainstorming. Luca?
Perfect. Thank you very much, Debbie. Let me share my screen.
By the way, we monitor the chat. So if you have any questions or anything, especially over the things that Luca's going to be presenting, please put them in the chat, and I or Mark or someone will try to answer anything you put in the chat. If not, we'll have a little bit of, if we can't answer it, we'll bring it up in the presentations and answer it by the end of the session.
Perfect. Thank you, Debbie. Can you all see my screen?
Yes.
Perfect. So welcome to the second part of our workshop on conducting research projects. So if you remember last time, we saw many aspects of the process, and today's overview will cover the basics of selecting computational strategies in data science. So it's going to be just an overview because we had an entire event dedicated to this. So we just wanted to reiterate the decision-making process involved in choosing between traditional statistics and AI and machine learning. So we just want to pinpoint the fundamental differences between these approaches. And the main goal of today's recap is to point you to helpful Python libraries for each strategy, so that those of you who don't know Python can actually have something to refer to as they learn how to apply these computational strategies in your analysis. So regarding the decision-making process between traditional statistics and AI and machine learning, I have to say that it's important to choose the right approach to analyzing data. And there are several key steps involved. So the first step is to clearly define the research problem or question that you're trying to address, because that's a factor that is important in your choice. And you must also consider the nature of the data you have, your research goals, and of course, the resources available to you in terms of cloud computing, infrastructure, etc. And based on these factors, we'll be able to choose the most appropriate computational strategy. So traditional statistics and more modern techniques such as AI and machine learning offer distinct approaches to data analysis. The main differences are that traditional statistics focus on hypothesis testing, inference, and the application of parametric and non-parametric methods. So it's more about interpretability and reliance on assumptions, and it has significant limitations in handling complex data sets. While in contrast, AI and machine learning prioritize pattern recognition in the data, predictions, so the development of predictive models, for example, and they are much more scalable. They manage complexity much better, and they have the ability to process large volumes of data very efficiently. And the only drawback is that AI and machine learning often trade interpretability for increased predictive power, meaning that sometimes they can look like black boxes where it's not really clear what process was done to draw those conclusions. And it can be difficult to understand their decision-making processes. But those are the main differences. So depending whether you're looking to test an hypothesis or to recognize a pattern in the data, for example, then your choice between traditional statistics and AI or machine learning might become really clear. And what do AI and big data enable over traditional statistics? So there are a wide range of more advanced analysis that go beyond traditional statistical methods. And some of those analyses are on this slide. So you can see predictive analytics or natural language processing or image recognition or even anomaly detection. And by anomaly detection, of course, we mean the identification of unusual patterns or data points that deviate significantly from the expected norm in the data. So in general, I'm going to say that AI and big data empower researchers to extract insights from very vast and complex data sets, and leading to conclusions that traditional statistical methods would not be able to reach. So they usually lead to more accurate predictions, and they can really support decision-making and problem solving. And like examples of those analyses that I just cited include, for example, the predictive modeling for disease outbreak prediction, or sentiment analysis of social media data, right, for public health monitoring. So those are the kind of analysis that AI and big data enable over traditional statistics. So in general, as a recap, I'll give you my recommendations. So as I said, it's important to consider the nature of the research problem that you're dealing with, the characteristics of the data you're working with, and the desired outcomes when you're choosing your computational strategy. And I would recommend that you assess the research objectives and the data characteristics before selecting a strategy. And that, of course, you remain always informed about emerging technologies and methodologies in data science, because especially with AI and machine learning, these methodologies evolve really quickly. And so it's important to keep yourself updated in order to adapt to these evolving technologies. And so again, it's important to make informed decisions. After this brief overview, I just want to go over some of the main traditional statistics techniques, not to give any real information on those because all of you are experts and you perfectly know what each one is about, but just to point you to some popular Python libraries for each one of them, so that those of you not familiar with Python can just refer these libraries and quickly learn how to start using Python to do what you have been doing, for example, with SAS, SPSS, or more traditional programs. So in general, we said that traditional statistics is, of course, robust, interpretable, and it's really well established, but it also has some weaknesses, as we saw. So it has limited predictive power, very often is assumption dependent, and it focuses on hypothesis testing. And some popular Python libraries in general, the most popular ones are NumPy, SciPy, and Pandas. But I'm going to show you for each technique which Python libraries you can use. So for descriptive statistics, which of course are about summarizing and describing key features of data, right, such as mean, median, standard deviation, etc. And it's something that you can use, of course, to understand the central tendency and the variability in healthcare variables, for example. The main Python libraries are NumPy and Pandas, and we're going to see them in a moment later on in the event. I'm going to provide more details about each of those. For inferential statistics, which is about making predictions or inferences about a population based on a sample from that population. And of course, it's something that you could use to draw conclusions about healthcare disparities, for example, from a subset of relevant data. The main Python libraries that we can refer to are SciPy and stats models. For hypothesis testing, so the evaluation of the statistical significance to determine whether observed differences are likely to be real or just due to chance. For example, you can use this when you're testing hypotheses about healthcare interventions or disparities. We can use Python libraries such as SciPy and stats models. For analysis of variance, so ANOVA, which is used to assess the statistical significance of differences among group means in healthcare or other data. For example, when you're trying to compare means across multiple categories to identify if there is a significant difference, you can use SciPy or stats models again. And you can use SciPy or Pandas to conduct analysis involving chi-square tests, which of course are for assessing the association between categorical variables in data sets or, for example, relationships between demographic factors and health outcomes. And in terms of what you can use for regression analysis, so to model the relationship between dependent and independent variables in the data, and you can use stats models and scikit-learn. For survival analysis, which is about analyzing time to event data. So for example, with healthcare data, the time until a patient experiences a particular health event. And this allows you, of course, to study disparities in disease progression or survival rates. You can use Python libraries such as Lifelines or stats models. And correlation analysis, which is used to examine the strength and direction of relationships between two continuous variables in datasets. So assessing associations, for example, between risk factors and health outcomes. You can use NumPy or Pandas. And finally, for logistic regression, which is used to model the probability of a binary outcome in data, and you can use Python libraries such as stats models and scikit-learn. Oh, right, there was another one, Bayesian statistics, which of course are about updating beliefs about parameters based on new evidence in a probabilistic framework. You can use PyMC3 or STAN. And time series analysis, which you're going to use to analyze temporal patterns and trends in data, for example, to study disparities over time in health outcomes for interventions. You can use stats models or Pandas. Perfect. And I would like to do the same thing now for AI and machine learning. So about those, I just say that AI, of course, encompasses various computational strategies, and it mimics human intelligence almost. And those strategies are implemented using different algorithms and techniques. And Python, of course, being very versatile, it offers numerous libraries for implementing AI strategies effectively. So we're going to see some of these. So machine learning, which, as you know by this time, involves the development of algorithms that enable computers to learn from the data and make predictions or decisions based on data. So this is without explicit programming, right? So learning directly from the data. And examples of machine learning techniques are, decision trees or random forests. And you can see on this slide some of the most commonly used Python libraries for machine learning. So scikit-learn, TensorFlow, Keras, and PyTorch. While deep learning, which is kind of a subset of machine learning that is inspired by the structure and function of the human brain. So it uses networks of they're called artificial neural networks. So they comprise multiple layers, and they're used to learn complex patterns from the data. And some examples are, you may have heard of those terms, so convolutional neural networks or recurrent neural networks. Some of the most commonly used Python libraries for this are TensorFlow, Keras, and PyTorch. Natural language processing, which is about giving computers the ability to understand and manipulate human language, and is used to conduct analysis such as sentiment analysis, for example, or name entity recognition, which is about categorizing specific elements within a text, for example. You can use NLTK, spaCy, or transformers. And there's ample documentation for each of these libraries on their websites, and I'm going to say more later. In terms of reinforcement learning, which is about training agents to make sequential decisions by interacting with their environment, it's used mainly in robotics, actually, in recommendation systems, which is more relevant to healthcare. You can use Python libraries such as OpenAI Gym or TensorFlow agents or stable baselines. And for evolutionary algorithms, which it's interesting, they are inspired by biological evolution, so they involve optimization techniques based on natural selection and genetic variation. So they mimic natural selection to solve problems by refining populations of candidate solutions. And they're used mainly in genetic programming or genetic algorithms. Some of the most commonly used Python libraries are DAP and PyGMO. Perfect. And now before we get to the next part, I'd ask Mark to please launch this quiz on traditional statistics and machine learning. And I'm sorry, I'm displaying actually the answer. I should have done that. Mark, can you please help me? Okay, thank you so much. So we have a question here.
The scenario does appear in the poll description, but the poll description doesn't appear in the present mode. But you can't have enough characters to present the scenario. But do you want me to share the slide with the scenario?
Oh, no, that's fine. Well, if it appears to our user, to our attendees, that's fine. I can explain it. So basically, in this scenario, you are a public health researcher. So you're trying to investigate the factors contributing to higher rates of heart disease among a specific minority population. And you have a
starting route to Grand Mart International Food,
which contains information
head northeast on Bucknell Circle,
including demographics, socioeconomic factors, health history, and access to healthcare. So you have this data set containing thousands of individuals. And the question is, which approach would be most suitable for analyzing this data to understand the disparities in heart disease rates? And you have a choice between traditional statistics, machine learning, or both traditional statistics and machine learning. Okay, perfect. Yeah, that's actually the right answer. Might have seen it on screen. But so of course, the reason why that is the right answer is that you can use traditional statistics to reveal basic trends, like, for example, correlations between, I don't know, income and heart disease prevalence across zip codes. So that can provide initial clues about potential disparities. And then machine learning can be powerful in health disparities research because it can really analyze complex interactions between various factors, and it deals really well with complex data sets. So by combining traditional stats for this initial exploration with machine learning for the more in-depth analysis, you can really gain that comprehensive understanding of all the factors that are contributing to those disparities. So perfect. Thank you for answering that. And I'm going to share my screen again. And in the next section, we're going to explore some of those Python libraries that we mentioned a few minutes ago. So first of all, well, we all know what is Python, right? I'm going to repeat it for those of you who might be new. It's a computer programming language. It's used in data science to do many things, including manipulating and analyzing data, creating data visualizations, building those machine learning algorithms. And it has many interesting characteristics. It's really easy to learn. So it uses words and phrases that are really close to everyday English. So it's really well suited for beginners. And it can be used for so many things. It has so many applications. It's completely free and open source, which means that there's also a really large and very helpful community out there to answer all your questions. And it's very popular. So you have lots of online resources to help you learn. And I'm going to point you to some of those in a moment. And of course, it's also the most used language by data scientists. So about 69% of machine learning developers and data scientists use Python for their analysis versus only 24% using R. So as I was saying, it's really easy to learn. It can take maybe 2 to 5 months or even less than that. But the good thing is that you can start writing your first short program in minutes, literally, just by looking at examples and changing the code to accommodate your needs. So it's really good to learn for people without any coding experience. And I'm going to point you to some of those resources later. The good thing about Python is that it offers a rich ecosystem of libraries for data science tasks. So some of the most commonly used Python libraries in data science, we're going to see now. What is a library, for those of you who don't know? It's like a collection of tools or functions that someone else has already built and packaged up for you. So when you're doing something, you're running some analysis, you're writing a Python program, and you need to do something specific. For example, let's say you want to create a plot. You can often find a library that already has all the tools that you need for the job. And there's plenty of documentation online. You go online, you study the documentation or look at examples and just replace, the variable names, for example, and there you go. You have something that works and enables you to run those analysis. You can actually do that on our shared workspace. I'll show you later our notebooks. We have examples showing how to access the data in the workspace, how to run analysis, and we try to provide explanations, step-by-step guides, and it's really simple to just go there and reuse that code. So in terms of libraries, these are some of the main ones. I collected here some of the main libraries used for data manipulation, analysis, and visualization tasks. So we're going to see each of them real quick. So NumPy, which is kind of the foundation for numerical computing. So it's really a fundamental package. You can use it for scientific computing. It provides support for really large arrays, which are ordered collection of items and matrices. And it's really efficient. It works really well with arrays for data storage and manipulation. It enables mathematical operations on large data sets. And it's kind of one of the most basic libraries. So it kind of lays the groundwork for data analysis with other more complex libraries, which of course can interact with NumPy. And I tried to put an example application for each of these libraries. So for NumPy, I selected, for example, calculating statistical measures such as mean, median, and standard deviation of health indicators, for example, across various demographic groups, just to give you an idea of what's possible. Then let's go to SciPy. So here we are extending our computing capabilities a little bit. So it's another open source library. It builds on NumPy, providing additional functionality, always for mathematical and scientific computing. So it offers more advanced algorithms for scientific computing that go beyond what NumPy can do. It includes tools for optimization, integration, signal processing, so some of those more complex things. And it complements NumPy, basically. So in terms of an example application, you could use SciPy to conduct hypothesis testing, for example, to evaluate the effectiveness of interventions in introducing health disparities, such as comparing pre- and post-intervention health indicators. Pandas, that's also a very commonly used one. So it's mostly about wrangling data, I would say, like a pro. So it's a really powerful library for data manipulation and analysis. It offers data structures, data frames, and functions for manipulating structured data in general, so table data. And an example of those data structures are data frames, right, for handling tabular data, as I was mentioning. And you can use Pandas for data cleaning, manipulation, and data exploration. It's really easy to use. It integrates seamlessly with all the other data science libraries that we are going to see today. And I'm going to skip the example, but I mean, you can use it to explore correlations, for example, between socioeconomic factors and health outcomes. Then Matplotlib, it's for visualizing insights. So this is the most comprehensive library for creating visualizations. They can be static, animated, interactive. It offers a wide range of plotting functions. You can create a wide variety of visualizations. You can customize them. You can, of course, integrate Matplotlib with other libraries for data exploration. So it's great. And an example application is creating visualizations such as bar charts or pie charts, for example, to illustrate disparities in healthcare access, right? For example, among different ethnic or socioeconomic groups. And something that builds on Matplotlib for stats is seaborn. So this library, it's a data visualization library. It's based on Matplotlib, so that makes sense. And it provides a high-level interface for creating these really informative and really attractive visualizations. And it creates visualizations that are probably even more aesthetically pleasing and informative than what you can do with Matplotlib. And it's really ideal to explore relationships and distributions within your data. So you can use it to create box plots, violin plots, to compare distributions of health indicators, for example, like, let's say, blood pressure levels among different population segments. And scikit-learn, so we are getting into machine learning here. And I titled the slide, Machine Learning Made Accessible, because it's a library that offers simple and really efficient tools for data mining, data analysis. So you can do classification, regression, clustering, dimensionality reduction, and it's really comprehensive. It provides support for various machine learning algorithms, and it really facilitates model building, model evaluation, and model deployment. So you can use it, to summarize, to implement machine learning algorithms to classify patients, for example, into different risk categories based on socioeconomic factors, right? And you can use it to predict healthcare outcomes such as hospital readmissions. Finally, we got to stats models, which you can use to dive deeper into statistical analysis. So it's a library for estimating statistical models and, in general, conducting statistical tests. And it provides support for a wide range of techniques, statistical modeling, econometrics, and it enables robust hypothesis testing, estimation, model selection, many, many things. And so it's ideal for in-depth statistical analysis of data in general and health disparities data in particular. So you could use it to explore correlations between socioeconomic factors and health outcomes, for example. And then TensorFlow is, again, about deep learning models, machine learning models, and specifically deep learning models. So it's an open source machine learning framework. It's developed by Google, and it's widely used for building and training deep learning models. So it's used, with large scale machine learning, and it enables building and training complex models for tasks, for example, like natural language processing. And I will cite an example application. You can use it to train convolutional neural networks, which we saw before, to analyze medical images and detect signs of disease or abnormalities that are, associated with health disparities, for example. And finally, PyTorch, it's really powerful, another really powerful deep learning framework, and it provides support for complex calculations across multiple processing units and devices. So it's really well suited to train large-scale machine learning models efficiently. And it's really user-friendly, by the way, so it kind of lowers the barrier to entry for deep learning. And it makes it really easy also to deploy those models in production environments. So it's really easy to use. And it can be used, for example, to adapt pre-trained language models for healthcare-specific NLP tasks. So NLP stands for natural language processing, of course, such as extracting information about social determinants of health from unstructured text data. Perfect. And Mark, I guess it's time for our quiz on this section. Can you please help me with this? Thank you. So my question is, which Python library is commonly used for data manipulation and analysis, offering data structures and functions for working with structured data? And perfect, I can see in real time that you got it right. It's Pandas. That's great. And I think we have another question. Mark, can you please display that? So which Python library is known for its statistical data visualization capabilities and is based on Matplotlib? Perfect. I like it. It's ScHARe. The right answer is ScHARe. You remember that, right? Great. It's, the something that was built on Matplotlib, and it enables, nicer visualization. It's really interesting. Perfect. I'm glad you got that right. And I'm going to go back to our slides. Perfect. So for those of you who haven't seen Python code ever, I just wanted to provide a screenshot of what Python looks like and what using some of these libraries looks like. So you can see on screen that in this example, we are using NumPy, and we are using it to simplify numerical computations and array operations in Python. So here we are calculating some summary statistics, for example, for health outcome data and detecting variations across demographic groups. And this slide gives me the chance to remind you about our notebooks, where you will be able to find examples for each of these, or almost all of them actually, but for many of these data science libraries. And you're going to find these examples in our Jupyter notebooks. I just remind you of what a Jupyter notebook is. It's an interactive analysis tool. It includes code cells for actually manipulating and visualizing data in real time. So they support several programming languages, so Python and R in particular. And they also support documentation to make it easier to share and reproduce your analysis. So we already covered in many past Think-a-Thons the basics of how to create your first notebook, how to actually explore the instructional notebooks available in our shared workspace. I'm going to show them to you actually in a minute. And so I'm not going to go over this in detail. I'm going to refer you to the previous Think-a-Thons that we held. The slides and the material is posted on our website. I'm going to ask Mark if he can please paste the link in the chat, so you can refer to those. And I just wanted to reiterate that if you're not familiar with programming, don't be discouraged, because the code in our notebooks is really easy to understand and use. And I think that our tutorials, that's my hope, they will help you understand how notebooks work, and you can easily cut and paste and modify our code and learn from there. And of course, notebooks are important. Knowing how to use them is important because they're now a major part of the data science workflow. So they can make your workflow more transparent, understandable, repeatable, and shareable, and allow you to work with your collaborators, make it really easy to do that, to communicate with them, to share your results, to do things in the easiest way possible. So here's a list of the notebooks that we make available in our workspace. And you can actually take a look at these titles, and then I'm going to show them live. So as you can see, and as some of you may know, we provide all these notebooks to so that you can add step-by-step instructions on exactly what's available on ScHARe. So the list of data sets that we make available, how to configure the environment, both for R and for Python, how to actually access the data, and perform some basic functions. So for example, plot it, save the results of your preliminary analysis. And we do this for all the categories of data sets that we host. And I'm going to go over those later. But if you remember, we host what we call Google hosted data sets and then ScHARe hosted data sets. So there are many categories, and we provide instructions on how to access each of those categories of data sets. So I'd like to show you at this point, real quick, what does it look like live. So this is our ScHARe workspace. You might recognize it. So for those of you who are not familiar with it, I'll just say a few words. It's a cloud computing workspace. It offers you the possibility of running analysis and collaborating with other colleagues and researchers. You basically have a dashboard where you can input information about your project. In this case, this is our workspace, so there's information on ScHARe with our mission, our vision, our frequently asked questions, and some instructions on the next steps. And then there is a data tab, and we're going to return to this tab later when we talk about the data sets. And what we want to focus on now is the analysis tab. So here is where you can actually find all those data sets that I just mentioned. So I'm just going to open one of them. You can just click on it, and it's going to display a preview. We're going to stop there. We're not actually going to open. But I just wanted to show you, for those of you who are new, this is what a Jupyter Notebook looks like. So you can see that there is text and guidance. And the second component is these cells that contain R or Python code, Python in this case. And it's really easy to click on the cell and run it from the main user interface. So all the code is already written for you, and you just have to run it, and you can experiment with it. You can change variable names. You can really learn how this works. So I'm going to go back to my slides at this point, because I'd like to point you to some of the Python external resources that we gathered from you. There are so many. There are so many online tutorials for beginners and advanced programmers at the same time. Each of those links is not just one resource, it's many of them. So I would invite you to actually explore each one of those. I'll give you some examples here. Like this alone contains like 30 plus tutorials to learn Python. You can see them listed on the right. And this other offers, a code class for beginners. Even Harvard offers a free Python course, which you can take advantage of. Coursera, of course, all the online learning platforms also offer free and paid Python courses. And here are some more, some free interactive Python tutorials from Learn Python, or, from Best Colleges has a list of the 10 places to learn Python for free, the best 10 places. So there are many, many resources, and I will leave the slides with you. They're going to be posted, so you'll be able to refer back to these. Great. So we went over computational strategies. We went over the Python data science libraries that you can actually run those analyses and use those computational strategies. And since we talked about regular analysis with regular data, I think it's important to mention that if your research project is about developing an algorithm, it's important to keep in mind that algorithms need to be tested and monitored as part of the process. And I'll tell you why. Of course, for those of you who are new or who may not be that familiar with algorithms are a finite set of well-defined instructions that are designed for computers to perform a specific task or solve a particular problem. So there's a logical sequence of step-by-step processes that the computer executes, and they enable efficient and accurate decision-making and problem-solving across various domains, including healthcare, and especially healthcare policy decisions. So how does it work in healthcare? Of course, the basis is lots of data, because hospitals, clinics, they collect tons of data about patients, right? So we have data about diagnosis, encounters, treatments, medications, etc. So it's really easy to use algorithms to analyze the vast amount of data that is available and to sift through this amount of data and try to identify patterns in the data, for example, to facilitate the decision-making process around healthcare policy decisions, for example. So where to allocate resources, or which treatments are most effective for a certain condition, or where the government, for example, or an organization should offer more services. So which populations it should target. So all of this sounds nice and helpful, but there's a catch. There's algorithmic bias. And we encountered this already many times. So algorithmic bias refers to systematic and unfair outcomes that arise from those algorithms that are being used for decision making, because they're either trained on biased data or there is a flaw in the design of the algorithm. And as a consequence, the algorithm ends up perpetuating or even amplifying sometimes existing societal biases in healthcare. And there are many points, many phases during the development and the implementation of algorithms where bias can creep in. And I thought it was important to list them. So bias can creep in during data acquisition and selection. And it can do that in many ways. So there can be sampling bias if the data that I'm using to train the algorithm doesn't represent the entire target population, for example. So there's missing data, there is just a sampling bias. And historical bias is another circumstance, right? So historical healthcare data, for example, reflects past discrimination. For example, some healthcare services might be used more by more affluent people than poor people. In this case, we have an historical bias that, of course, is going to be reflected in the data. Another point in the algorithm development process where bias can creep in is the feature engineering phase and the model design phase. So if I'm developing an algorithm and I'm choosing the wrong features, this can lead the algorithm to make unfair decisions based on factors that were irrelevant. And there could be limitations in the way I design the model or in the model itself that can also lead to bias. Another part that is important to keep in mind is the model training and evaluation phases. So there could be issues with training data quality. So training data could be inaccurate or it could be incomplete. And in terms of the evaluation metrics, if we focus solely on overall accuracy, for example, we might mask disparate impacts on different populations. So we need, even with evaluation metrics, we need fairness metrics that assess how the algorithm performs across different subgroups. And the subgroups could be race-based, ethnicity-based, socioeconomic status-based. So it's really important to keep that in mind. And in the implementation and monitoring phase, we could have issues with limited transparency, for example. So some of those algorithms, as I mentioned before, are kind of black boxes, right? So it's really hard to identify and mitigate biases. And there could be unintended consequences. So even the best developed, the most well-intentioned algorithms can lead to unintended consequences sometimes if they're not continuously monitored for potential biases emerging like in the real world use as opposed to in the lab. And I would like to conclude here saying that it's really important to test the algorithm. So it's really crucial during the design phase. It ensures the reliability and validity of algorithms before implementation. And it really enhances the accuracy and effectiveness of those algorithms in real-world applications. And for the monitoring of algorithms during the implementation phase, I'm going to say that it's really important to also do that monitoring because data is evolving, right? Real world use is evolving. So the data an algorithm is going to encounter in real world might differ from the training data. So it's really important to monitor that. There could be unforeseen consequences. As I said, even well-designed algorithms can have unintended consequences, so we should monitor for those. There could be shifts in societal biases, for example, because those are also constantly evolving, as Dr. Duran was saying before. It's impossible to eliminate biases, and they're constantly evolving. So monitoring helps ensure that the algorithm doesn't become biased due to changes in the social landscape. And finally, another, last but not least, I would say, another factor why it's important to monitor algorithms during implementation is because we really want to build trust and transparency in AI. So if we monitor algorithms regularly, that demonstrates our commitment to fairness, and it helps build trust in the algorithms used for those healthcare policy decisions. So we should try as much as possible to avoid perpetuating bad AI. So we should always try to identify potential sources of bias in the data, in the sampling procedures, in the variable selection, etc. In all those phases that I just demonstrated. And we should also utilize bias mitigation techniques. Like, there are so many. We went over those. I would actually refer you to the past session because we had a really detailed overview on those. But those techniques like data balancing, weighting, fairness-aware algorithms, they can be used to mitigate bias in the data. And then it's really important also to promote transparency and responsible AI practices. And we had an entire session on that too. So it's important to document the limitations of the data and potential biases to ensure responsible use of AI models. And of course, there are, if you're developing algorithms, there are also many legal and regulatory frameworks that you have to comply with. So there are mainly anti-discrimination laws, prohibiting discrimination based on protected characteristics such as race, gender, or age. There are privacy regulations that you have to keep in mind because, of course, individuals' privacy rights must be safeguarded. And ethical guidelines that are provided by professional organizations or government agencies that you have to comply with. And especially with ethics, it's really important to advocate for responsible AI, whose principles include fairness. So try to ensure that algorithms produce unbiased outcomes across different demographic groups. Transparency. So making those algorithms transparent and understandable to stakeholders. So make sure that they provide also explanations for the conclusions they reach. And then accountability. So holding developers, organizations, users accountable for the impact of algorithms if those decisions are not verified with more data, for example. And then privacy. So protecting individuals' privacy rights and sensitive information. So again, adhering to these ethical principles is essential for building trust and mitigating potential harms associated with AI. So I wanted to remind you of that. Perfect. And Mark, we are at the end of this section as well. So I would ask you to display the quiz. And we have one question here. To mitigate bias in algorithms used for real-world applications, it's important to only use the algorithm datasets with perfectly balanced representation, or continuously monitor the algorithm's performance across different demographics and adjust as needed, or focus solely on optimizing the accuracy of the algorithm during development, or limit the complexity of the algorithm to ensure easy interpretability. So I would invite you to respond. Give some time to do that. Perfect, that's the right answer, of course. You have to continuously monitor the algorithm's performance across different demographics and adjust as needed. Perfect, I'm glad. And actually, Mark, there should be another quiz, I think. Exactly, so societal biases can potentially be reflected in algorithm output because algorithms are inherently malicious and designed to discriminate, or algorithms are completely objective and are not influenced by external factors, or algorithms learn from data which can contain societal biases, or finally, algorithms are programmed by biased human creators. I'll let you answer this. Thank you, Mark. Yes, I guess we can show the results. Perfect. I like seeing both, because actually there wasn't one single right answer. There were two, because of course, algorithms learn from data, which can reflect societal biases, but sometimes they're also programmed by biased human creators, even if they're well-intended. So I like that you considered both options here. Perfect. Great. So I'll go back to our presentation. And the last thing that I want to talk about today, before we get to the brainstorming phase, is something that is really important to keep in mind as you conduct a research project. And again, we had an entire session on transparency and reproducibility. So I just wanted to mention again that open science is this kind of paradigm shift in research practices aimed at fostering transparency, collaboration, and accessibility, right? So it promotes the sharing of research data, methodologies, findings, and the goal is to accelerate scientific progress and innovation. So there are many principles promoted by open science. I listed many here. So one is open access, which is about making research findings freely available online. So this is what you should aim for with your studies, often through open access journals or repositories. And then open data. So getting into the habit of sharing the raw data used in research studies so that others can replicate your studies, your analysis, and come to the same conclusions or analyze a different aspect. Open methodology. So making not only the data or the results available, but also the research methods and protocols used in a study. And then open source. So using and sharing open source software as much as possible for data analysis and all the other research tasks. And some other principles, open peer review. So making the peer review process more transparent, allowing reviewers' identities or comments to be disclosed to some extent. Reproducibility. So conducting research in a way that allows others to reproduce the findings, as we said. Collaboration. So encouraging researchers to work together and share their findings openly, which is something that our workspaces on Terra enable you to do really easily. And public engagement. So once the results and the findings are there, communicating those findings to the public in a clear and understandable way. So not just to the scientific community, but also to the public. And NIH, of course, embraces open science, and ScHARe embraces open science because it's crucial to advance knowledge discovery, to improve reproducibility of research, and to promote public trust in science. So the NIH has a new data sharing policy, as I'm sure many of you are aware. So they implemented a new data management and sharing policy in January 2023. The goal was to promote transparency and responsible data management in scientific research. And the data sharing policy affects researchers that apply for NIH funding. So all the grants, all the contracts at NIH, and also its intramural researchers conducting research within the NIH itself. And again, the core principle here was to maximize the appropriate sharing of scientific data. And of course, there are, many benefits of data sharing. So data sharing enables verification and reproduction of findings, and I stress verification, and fosters collaboration among researchers, accelerates science progress, and it increases also the impact of funded research. So what data needs to be shared based on the NIH data sharing policy? So all the scientific data generated from the funded or conducted research, with some exceptions. So there are exceptions for data with privacy risks, for example, or commercialization potential or security concerns. And the way this happens is that data is shared, but researchers must submit a data management and sharing plan outlining how they will handle data, how they will ensure its quality and security, and where they will deposit it. So in a suitable public repository. And that was actually my main point in all this section of the talk, because I wanted to point you to the fact that the ScHARe repository is actually designed to meet the data sharing requirements of the NIH data sharing policy. So for those of you at NIH, it's the perfect place to host your data, right? So its intended purpose is to serve as a centralized platform for storing, managing, and sharing research data related to health disparities in particular, and social determinants of health. And it adheres to the FAIR principles, which we all know as well, so findable, accessible, interoperable, and reusable, to ensure data discoverability and usability. And of course, as we said, it supports open science initiatives and promotes collaboration, as you're seeing, right? As with the research think-a-thons, with the workspaces. And its main characteristics, its innovative characteristics, is also that it focuses on common data elements, which, as Dr. Duran said, are basically standardized, precisely defined data points used consistently across different research studies. So it's basically using the same way to ask for a certain parameter, for a certain data element. Like, for example, it could be age. Asking about age consistently enables to have these building blocks that allow you to compare data across studies and to really enable interoperability between different data sets and different studies. So it's a way of standardizing data and metadata to facilitate data reuse. And the ScHARe common data elements are actually published in the NIH CDE repository. They can even be downloaded into RedCap. So it's really easy to use them. And there are many benefits if you use them. So of course, standardization is one. It ensures consistency in data collection, right? And reporting also across studies. It makes the data more interoperable. So it facilitates data integration and comparison between different data sets and projects. And it makes the data management process much more efficient. So it reduces errors in data handling and redundancy. And of course, it promotes collaboration and data sharing among researchers and across different projects and different institutions. And of course, there is something about data quality to be said as well, because it enhances data quality and reliability, because we are using standardized data and standardized data collection practices. And here are some of the, all of the labels for the ScHARe core CDEs. You can see them listed on the screen. You can see that it's a mix of some demographic factors and also some social determinants of health CDEs. So we have age, birthplace, but also, for example, education, English proficiency, disabilities, health insurance, employment status, usual place of healthcare, financial security or social needs. And we also have 2 project level CDEs, which you can see bolded there. And all of these CDEs are NIH endorsed, actually. So we are the first institute that has that. And they are published in the NIH CDE repository, the link for which you can see on the top of the slide. So I would encourage you to visit it and to look for the ScHARe CDAs there and to use them for your studies. Mark, I'm going to ask you for your help, please. So if you can display this quiz on screen. So let's see the question. The core principle of the NIH data management and sharing policy emphasizes restricting access to all scientific data generated by NIH-funded research, or maximizing the appropriate sharing of scientific data while considering ethical and legal limitations, encouraging the publication of research findings in open access journals only, or prioritizing data privacy over all other considerations. I'm going to give you some time. This is an easy one. Thank you, Mark. Perfect. That is it, of course. Maximizing the sharing of scientific data while also considering ethical and legal limitations. Perfect. Mark, can you go to the next one? I believe we have another one. Please. Okay, so which of the following is a primary benefit of using common data elements? So standardized variable names, units of measure, as I explained. It improves data security and privacy. It simplifies data analysis and comparison across studies. It reduces the overall size of data storage requirements. It enhances the visual appeal of data presentations. So what's it going to be? Thank you, Mark. Perfect. Simplifies data analysis and comparison across studies. That's great. Perfect. I'm pretty happy with that. So I'm going to go back to our slides because it's time to brainstorm. Before we do that, let me explain what we are trying to accomplish here. So we'd like to brainstorm health disparities research ideas for the upcoming research Think-a-Thons. So we would like this to happen in a way that considers innovative approaches and methodologies, such as AI, at least in part. We're going to have groups that are going to focus on like more traditional methods, like traditional statistics, so that all of you can feel at ease. But if possible, we would also like to consider more innovative approaches and methodologies, at least for some of the projects. And we'd like this to happen using the data sets that are publicly available on ScHARe. So the research projects should hopefully be about health disparities, so you all know what health disparities are, so I'm not going to go over that. I'm just going to remind you that health disparities are about disadvantaged populations in comparison to a reference population. So you can see the populations with health disparities listed on the right there. So it's not only racial and ethnic minority groups, but also people with lower socioeconomic status, underserved rural communities, sexual and gender minority groups, and people with disabilities. And health disparities are about health outcomes, and they are categorized there as higher incidence or prevalence of disease, premature or excessive mortality from specific health conditions, greater global burden of disease, poorer health behaviors and clinical outcomes, and worse outcomes on validated self-reported measures, right, that reflect daily functioning or symptoms from specific conditions. And I know all of you know this, but I just wanted to repeat it so that we can keep it in mind as we discuss potential projects trying to identify some of those health disparities. And of course, inequities can lead to health disparities, and the social determinants of health are going to be crucial in our research projects, right? So education access and quality, healthcare and quality, neighborhood and built environment, social and community context, economic stability are all factors that play a role. So if certain communities have less access to good education, jobs, fresh foods, healthcare, whatever, they might face more challenges in staying healthy, or they may not have the same opportunities to make healthy choices. So our analyses are going to focus on the social determinants of health in some way. And we are interested, of course, in determining how these non-medical factors interact with each other and potentially also with biology to influence health. And AI may help us find the answer for those groups and projects that are going to focus on AI techniques. And we tried to put together something that might be helpful for our discussion. So we try to list here some of the research gaps in the current health disparity research landscape. It's by no means an exhaustive list. There are so many more. It's just a couple of suggestions for our discussion, and please feel free to add more later on when we talk. But areas with limited research in the current health disparity research landscape include interactions between the various social determinants of health. So there's a gap in understanding the complex interactions between SDOH factors and how they contribute to health disparities across different populations. And another gap, which I'm going to mention next, is about intersectionality, because traditional research focuses on single demographic factors such as race, gender, etc. But how do multiple social identities intersect and influence health outcomes? So, for example, if we have a Black woman who is also LGBTQ and immigrant, what difference does that make? Where many factors are interacting together. And then another very interesting topic is precision disparities, the so-called precision disparities. So it's about the rise of personalized medicine using genomics is raising concerns, right, about potential disparities in access and benefits. So are we creating what we call precision health disparities? How do genetic and social factors intertwine to create those? And then we have, of course, the role of implicit bias in healthcare. So how does that affect treatment recommendations, patient experiences? What interventions can we imagine to mitigate their effects? What are effective? And digital divide and disparities is also something interesting. And we try to pick these because there were so many gaps. So we try to pick gaps that we have data for. So for example, we do have data on internet access, for example, or access to broadband internet. We have, if you see point 6, we have data on environmental exposures, etc. And we have longitudinal data, right, as we said. So we tried to make this more helpful. So as I was saying, digital divide is also a factor, so lack of access to technology and how this can exacerbate health disparities. And environmental exposures, of course, we know that communities of color and low-income populations are often disproportionately exposed to environmental hazards. So what are the long-term health effects of these exposures? And finally, many of these studies on social determinants of health or health disparities are cross-sectional. So it's a snapshot, but we lack longitudinal studies that actually track individuals over time, right? And those would be really crucial to understand the progression of disparities. So I'm just gonna mention, remind you actually what data is available in the shared data ecosystem. So as you know, we provide a lot of SDOH related data. We're going to explore actually the available data sets real quick, just to show you the steps that you need to take if you want to do that in preparation for our research Think-a-Thons, which are going to start next month, so that we're going to assign some kind of homework to you, so that before the next event, you can actually go and explore all the data set that we have and maybe come up with some potential ideas for research projects based on your interest and your research questions and the data that you find available on the platform. So as a reminder, we have 3 categories of data. We are not interested in the third one right now. We just focus on the first 2. So we do have available on ScHARe the so-called Google-hosted public datasets, which are publicly accessible, federated and de-identified datasets that are actually hosted by Google through the Google Cloud Public Dataset Program, and they are made accessible through our notebooks. It's really easy. There's actually a notebook explaining how you can access those, and there's a full list of datasets from the Google program that is available for you to see. An example of these datasets is the American Community Survey, for example. And the second category is what we call the ScHARe-hosted public datasets. Again, these are publicly accessible. We have no PII datasets, for example, for now. So every dataset is going to be publicly accessible, de-identified, and this category we host. And an example is the Behavioral Risk Factor Surveillance System, the PERFIS dataset. So to give you some names, these are some of the Google-hosted datasets that are accessible through ScHARe. I'm sure you can recognize many names. So ACS, American Community Survey, US Census data, Air Deprivation Index, and many more. Point-in-time homelessness count, CMS data, Medicare, and many COVID-19 datasets as well. So there are many of them. And in terms of the ScHARe-hosted datasets, they are organized based on the social determinants of health. And I'm going to show you in a moment. So to give you some examples for each of those categories, to which we added 2 of our own, I'm going to show them to you. But for the first category, education access and quality, we do have data on graduation rates, school proficiency, early childhood education programs, interventions to address developmental delays, etc. And you can see some of the data sets that we host mentioned here as examples. In terms of healthcare access and quality data, we do have data on health literacy, use of health IT, preventive healthcare, health screenings, family planning services, access to telehealth, etc. And you can see some examples listed here, right? So data on the cost and use of healthcare and health insurance coverage or primary care access. Then in terms of neighborhood and built environment, we do have data on, as I said, access to broadband internet, access to safe water supplies, toxic pollutants, etc. And again, please see the examples below. So we have data on environmental indicators and health, exposure, hazard data, etc. Social and community context. So we do have, for example, the hate crime statistics by the FBI, so data on crimes motivated by bias against race, gender identity, religion, disability, sexual orientation, etc. And and the general social survey, so data on a wide range of characteristics, attitudes, and behaviors of Americans. And so data on experiences of racism and discrimination, for example. Economic stability. So here is where we host data on unemployment, poverty, housing stability, food insecurity, etc. So an example is the Food Access Research Atlas. So food access indicators for low income and other census tracts. And then we do have data on health behaviors. So that's one of the categories that we added. So data on health-related practices that can directly affect health outcomes. You can see 2 examples here, PERFIS and the Youth Risk Behavior Surveillance System as well from the CDC. And then that's the second category that we have. So diseases and conditions, data on incidence and prevalence of specific diseases and health conditions. An example is the chronic disease indicators by the CDC. Great. So how to check what data is available? You can do that in 2 ways, or actually 3. So one way is to go to the Analysis tab in the ScHARe workspace, and I'm going to show you in a minute. And the first notebook that you're going to find in the Analysis section lists all of the data sets available on ScHARe. So that's one way. The second way, which is going to be easier, you can just scan this code, or, I would actually ask, Mark, can you please paste that link in the chat so maybe it's easier. So this is a link to a document, a PDF document that lists all of the data sets available on ScHARe, and we are adding more actually as we speak. So we might have an updated version soon. And so that's another way. And the advantage of this is that this file contains descriptions for each data set, so you can really see what the content is going to be for each data set. And now I would like to show you, to take a look at the platform, and we are going to see how to access available data on ScHARe from the Data tab. And this is something that I would invite you to do at home in preparation for the next event as you think about potential research projects. So I'm gonna show you real quick. So this is our workspace that we saw before. You recognize it, dashboard, data, analysis. Before I get to the data, I'm gonna show you that this notebook here, the first one, actually lists all of the data sets available on ScHARe. It's the same content as the PDF file, so we'll probably use that. And from the data section, I'm going to click on data here. And I wanted to show you that you can actually access all of the data that we host. So the ScHARe hosted data sets. You can see that there are some categories on the left. There is a list that comprises all of the data sets that we host. So it's more than 240. And then next to it, we have categories listing each data set based on the category it belongs to. So for example, we have disease and condition, or education access and quality. And you can see that as you click on the category, the data appears on the right. And the way this works, you have multiple columns. So each of the rows is a data set, of course. So you have information on the name of the data set, the size, and the category it belongs to, the year, because for many data sets, we have multiple years, and then a link to the data, actually, in case you wanted to download it, and instead of using it directly in the notebooks, and then links to the data dictionary, information on the file format, a link to the homepage, so to the source of the data, etc., and many more data points, which are going to be helpful. And there's also a way to search from here directly. So if you're looking for, I don't know, graduation, for example, you can use the search box and do the search. And of course, all the data sets containing graduation rates are going to be displayed. There's also an advanced search. You can use like Boolean operators. And so my invite to you is, to really examine this list or the PDF file that we make available. And then once you find something of interest, to actually check that the data set you're interested in using actually contains the variables that answer the research questions that you have in mind. And to try to really think of potential research projects based on actual research questions and the actual data available on the platform. So that's my invite. Perfect. And I now go back to the slides for one last thing before the actual brainstorming can start. So we wanted to give you a few ideas just to start with, not because they need to be what we focus on, but just to show you what potential projects could be that leverage AI and big data, using the data on our platform. So this is one example, geospatial analysis of environmental factors. So the objective here could be to explore the impact of environmental conditions on health outcomes, especially in minority communities. So the idea here could be to combine the environmental data sets that we have on like air quality, pollution levels with health records using geospatial analytics, and then use AI models that can reveal special patterns and that can help identify areas with higher health risks in minority populations, for example. And to give you some specific examples, here are some of the data sets that we could use: the APA air quality data, or the Health and Nutrition Examination Survey, which contains data on respiratory health indicators. And these are some of the AI tools that we could use. So geospatial analytics tools, such as JS platforms, or to map environmental data and health outcomes, or machine learning for spatial analysis. So algorithms that perform spatial regression or clustering to identify areas with higher health risks. So that's the first project. A second one is about education and health disparities analysis. So we could think of examining the link between educational disparities and health outcomes in minority communities. And the methodology here could be to merge educational attainment data with health records, applying AI techniques to discern patterns. And we could explore how educational opportunities influence health behaviors or preventive care, or just overall well-being. And to give you some specific examples of datasets and AI tools, I would say that we do host the National Center for Education Statistics data, and that contains data on educational attainment by demographics. And we also have BERFRS, which includes self-reported health data and behaviors. And in terms of AI tools, we could do some predictive modeling, so utilize algorithms like just regression and neural networks to predict health outcomes based on educational disparities. And in terms of causal inference techniques, we could also apply methods such as propensity score matching to isolate the impact of education on health. And these are just examples. I mean, the possibilities are endless. And the third and last project that I'm going to mention before turning it over to you, Debbie, for the last brainstorming phase, is about trying to identify causal links between chronic stress associated with social adversity and health disparities. So we all know that health is adversely affected by social disadvantage. So neighborhoods influence health through their physical and geographic characteristics, including air water quality, proximity to health promoting or health suppressing features. And we also know that chronic stress of social disadvantage, socioeconomic inequality, and racial discrimination can influence health. And it does that through a variety of biological pathways. So we could try to examine the role of epigenetic modifications as a causal link between chronic stress associated with social adversity and health disparities, and the impact of any mitigating factors. And this could be something that we could do in partnership with also other institutes. And these are just ideas. And I would actually welcome suggestions from you in terms of what we could do. So I guess at this point, Debbie, I think I'm going to turn it over to you for the brainstorming phase. And I would ask you, what research projects do you believe it would be worthwhile to pursue? Debbie.
So I've been paying attention to some of the comments in the chat as well.
Mm-hmm.
And, I'm glad for some of the comments in there, because I think one that I really resonated or appreciated is that, yes, our ScHARe approach to this endeavor is to really include people who are in the community, as well as new investigators and people who are not always doing data science types of research. And I think that, I myself, I sit on many, many committees like Bridge to AI, collaborating with Aim Ahead, and all of those kinds of projects like that. And especially in our big projects, in basic science, we don't have a lot of underrepresented populations, and they don't really pay very much attention. They pay some, but not a whole lot, to community involvement. But I just also, and I put it in the chat, and I want to explain what I mean by this. Having sort of a community-based research approach is a 360 issue. It's not just a 180 issue. And what that means is this. We are, and all of us on this call, I'm sure, have that intention to be inclusive, representative of the community, focus on getting community voices into what we do. And I can give you a real good example that was just presented at a research project or a meeting last week with RADx Up. They used the 50 CDE measures that were used in Recover, which is for long COVID. And they brought it into their community research project. And the community didn't resonate with any of the 50 CDEs being used in the Recover project, and then came up with 27 that was more relevant to their living conditions and their life. So it is really good and very important that we include community perspectives. What is difficult, I think, in the AI world is that there's a lot of misinformation out there about how bad AI is because there's biases and criticisms. Generative AI is merging faster than we can even keep up with, anybody can keep up with. And there's lots of concerns. There's the use of synthetic data for minority populations that hasn't been validated to be as an effective approach, especially in clinical trials and drug development, but it's commonly done. So we have a lot of issues. And this is why we are investing in this platform and doing these kinds of things that we're trying to do now with the Think-a-Thons, so that we can educate you all to also then go back into the communities that you work with and educate your communities. Because the communities also have to upscale their knowledge base about AI, cloud computing, and how to ask the questions. When a medical device is used, or a physician or care provider uses a AI approach to their diagnosis or treatment. So it's a 360 issue, and that's what we're trying to really highlight as we do this kind of research. So we're gonna open up the screen. I asked Mark to set up a Slido slide that we can just prompt. And you can just add comments to, but I also want to encourage some of you to talk and think about what types of research projects would be good for us to really look at. We gave you many examples here, but I also know that you are involved as a community. It's because there's so many people on the call, I ask that you turn your camera on when you speak, but turn it off when you're done, because it just can't handle everything. So turn your microphone and your camera on when you want to speak, and then go ahead and turn it off. And the reason this is really important is because not only do we want to teach you to do ethical AI research, because it is possible to be very ethical and transparent. I personally do not believe it's possible to create AI that doesn't have some biases. But as Luca presented, and as I said, it's not that we can do that without biases now, but that we have to pay attention to it and identify it and fix it before it creates harm. And that's why we think it's very important for all of you to be involved. So Mark has put on what research do you believe are worthwhile to pursue? You can type it into the Slido, please. And also, I'm interested in your perspective on how to do this kind of cloud computing, big data research, because one of the things that we also see is that we have to create this mind shift, this paradigm shift that looks at big data in a way that unveils more information than we thought. And Luca made this point as well. I'm going to give you one in genomics, and I can't remember exactly the data for this, but it was, like people had identified like 170,000 SNPs. And because of AI and the machine learning process, it was unveiled that there was actually another 300,000 more than what we imagined. So we also have that opportunity in health disparity, healthcare delivery research, because we can look at more variables. We can look at social determinants of health. I believe that social determinants of health are the reasons that we have health inequities. And if we can understand the social determinants of health in interaction with each other, then we might be better able to create more meaningful interventions, especially when we cannot, as a community worker, you're not going to change poverty. You're not going to change lack of education. We just can't do it. But what can we do to facilitate some sort of change? So please turn on your camera and speak up and add projects to the chat. Jane, I see your camera came on, but you're on mute. Turn on your camera and unmute.
Right.
There
I
you go.
did not know to place my proposed study that I need to look at, me and a couple of my colleagues, but I put it on the chat. So I see Aluka looking like you can merge two data sets together, but this is what we are trying to kind of look at the determinants of health analysis based on experience, kind of again from analyzing visual, all that with MedStar, children's data survivor nationwide cancer incident on mortality with social determinants of health. So that's kind of, but now, listening to Luca with how we can match those two data sets, maybe we need to go just use the existing data sets. But we're trying to look at the patient's record from the MedStar, actually.
Yeah. Electronic health records are always helpful because they are connected to real health data issues. I think oftentimes when we use national or federated data sets, we're looking at issues on a more of a population base rather than an individual base, which also has merits, right?
Yeah.
And we have to all continue to do those kinds of research. So I'm glad you're using MedStar to do these things.
Yeah, we're trying to see, but I might go a different way. This is just we're trying to do for a small pilot study with our grant at the Georgetown Howard University grant. But for me, being from the social science, I always like to look at the social determinant of health with chronic diseases and lack of insurance or whatever type of insurance they might have.
For those of you, if you don't know, NAMS, the National Academy, today actually has a session on the social determinants of health and the biological impacts.
Mm.
And I saw in the Think-a-Thon, I mean, in the chat, someone was talking about environmental factors. And one of the presentations today was really about how toxins and pollutions in the air actually create DNA changes in individuals. And those individual DNA changes actually go into the birth of the child. So we have a lot of things to study to understand.
Right, right.
Chris?
I have more of a general question.
Okay.
You mentioned at the beginning that you use Terra in order to take advantage of the other platforms that are on Terra. So I've been doing work in All of Us lately, and I'm just curious if you know of any general projects that are able to use data across, say, those two platforms, ScHARe and All of Us.
Yeah, actually, we're very much working on that. We're collaborating. In fact, one of the slides I showed was that we have a Terra interface between them. So we can actually share data across the platforms. In the platforms like All of Us, and in the platform like Aim Ahead, who uses MedStar electronic health records, you cannot download the data onto your laptop, but you can create workspaces on the Terra platform in their space and use the data. So that is why we really spent quite a bit of time, and we have several presentations and slides if you want to go on our webpage that actually walks you through how to use Terra, because you can't, it's not an easy, intuitive thing to do. I think we have like 4 or 5 sessions on how to do Terra. So, and there was another question in the chat that I just saw, and I'm going to tell you that, tell everyone on the call, we are working on a tool as part of our repository that actually allows you to combine data sets simply by moving variables into a here's your 2 data sets and you have the middle, and you just move the variables into the middle, and you're creating an aggregated data set of the 2 different data sets. You're creating an aggregated data set. We are doing this as a drag and drop so that it becomes very easy for you to combine data sets. The prototype is already done. We use it in demos now, but it's not going to be available to public use until fall. But I will look into using it for our 4 Think-a-Thon groups, research groups, so that we could potentially use that tool as kind of like pilot testing it. So hopefully we can use that for those of you who want to participate in our research Think-a-Thons. And I see that many people know this is a good idea. And I mean, it's been one of the biggest challenges, and this is why we really wanted our contractor to really work on this combination of data, being able to combine data sets. I'm not sure I'm going to pronounce your name
Yes.
correctly.
Yeah, just call me Yetem, Y-E-T-E-M.
Okay,
That's
Yetem.
too long. Yeah. So about the research project, like worldwide, to pursue about immigrants' health services utilization. Even if there is a service, if they use it like as needed. And I have done a dissertation on that, and what I found out is a lot of people, they just wait until they get really sick. So yeah, that was, I I have tried on only one community, and it's good to, it's worth a while to pursue that on different, country, immigrant from different country.
Well, yes, that is an issue. There's a couple reasons for it, right? Fear of deportation, fear of cost,
Yeah.
sometimes lack of
Education,
knowledge.
yeah, there are so many, yeah, there are so many things like, education
Right.
and transportation and the income and all that. So, it's
It also, we also see that same issue applies to many people who are poor.
yeah,
So, and I think the factors are probably very similar other than deportation. Lack of transportation, the lack of understanding of healthcare. And honestly, and this is why I've asked every group I'm involved in to quit headlining that AI is biased or healthcare doesn't work, because when we put out messages like that, we instill an irrational fear in people that don't have the knowledge and health literacy, the computational literacy, the health literacy to ask important questions.
and culture too. Culture has a lot of,
Yes.
some
Yeah.
people.
But in your case, it looks more like access to healthcare and whether they have health insurance or not. So the other important variable would be looking at how the use of emergency rooms, because they wait till they're very sick, and you can use to see how often they use emergency
Right.
usage with the migrants.
Another issue with immigrants, though, is that they often live in rural areas and there's no healthcare facility.
That's another thing.
That's
If you do it nationwide, if you want to limit it to the cities, that's inner cities. But what data set would that be? You'd have to use probably one of those CDC data sets, or
my guess it would be more like maps. I did see, I asked Mark to scroll so that we can, because it doesn't go. And so I'm asking him to scroll so that everyone can kind of see what people are putting in. And then you can vote as you see something you like. And one of the things that I saw while we were talking just now is loneliness and social connection. And I think that has emerged, especially from the COVID lockdown, as such an important issue in health. And honestly, the other thing that I think we don't do a good job of is that we only talk about social determinants of health in a negative way. Sometimes the social determinants of health, like community involvement, community connections, are protective factors. So we have to understand the social determinants of health, both in asset and deficit.
very, very true.
So we really want people to talk a little more. So I know you're all, unless you're just, there and let's see, it's 4 o'clock. So you're having your last cup of coffee of the day. We really need to hear and see what some of the things are important to why you're on this call and what you want to get out of these kind of research projects. Ready?
Hi.
Hello. Oh, go ahead. I'm sorry.
We'll do
Okay.
you next, Ollie. Ready?
Hello.
Let me go in order of screenshot on. So Preddy?
Greetings, everyone. This is really a fascinating session today, brainstorming of ideas. I'm a public health professional with background in aging and health disparities. I also worked in virology lab for a very long time. So vaccinations and long COVID and adverse outcomes, because it's really complicated, as Dr. Doran was suggesting. How do you even measure, systematically measure long COVID? It's a very novel thing right now, and there's so much novelty going because we don't really understand the different codes. What are the different symptoms? And what I'm also part of the Women's Health Initiative group, where we've been looking at a frailty, which is also a very difficult thing to measure, especially when it comes to older adults. And how does that relate to long COVID? So there are another area of mine is preventive services. And recently I've been focusing on a combination of preventive services, such as dental care, and also some of the long-term, and Dr. Luca mentioned longitudinal data sets. So the effects of delayed dental care to manifest years, and it takes years to manifest. So having a longitudinal data, which is really a gap, to look at periodontal disease, or and how does that lead to multimorbidity, or how does multimorbidity interact with other things like, and so there's a lot of like forward and backward mechanisms that are going on, and bidirectional relationships. So I think these data sets can really help tease out those things.
Thank you. And one of the things that we encourage all of you, we have tried to search through thousands of data sets. So if you have data sets available and they're not in our system, you can simply email us the name of the data set or how to do it or where it can be located, and we will get it into the data platform. That is not an issue. And so please, anything that you feel is important, you can email Luca or myself, and Luca will put his email in the chat as well as mine so that you can do that. Ali, Amit, I think you were next, and then Debo. Ali?
Hello. I just wanted to say the reason why, what brought me to these brainstorms is because as a student, we were working on clinical research, health disparity research. And I saw that this was a part of the National Institute on Minority Health and Health Disparities. And so that's what brought me here, because I wanted to research health disparities.
Good, I'm glad, because we need a lot of help. So welcome, and I hope you participate in one of our research Think-a-Thons starting next month. Debo?
Yeah, thank you very much. And good afternoon, good evening, and good night and good morning, wherever you are.
That's right. People
So,
from all over.
all over, yeah. And I think the area that I'm very much interested in is the area of occupational health. And one thing I've been looking at is the impact of robots in the workforce. And we've talked about the positive impact of robots, introduction of robots in the workforce, but we hardly look at the negative impact in terms of mental health in relation to age, gender, race, skill level, and job type. And this is one of the one important study that I'm really interested in, to not the physical effect of robot, but the mental health of robot as it affects the different socio demography and socio-cultural group. And one thing that we have to realize that before used to be that, and the concept people used to have is that someone is coming to take their job, but now it's the robots that is taking their job. So, and how are these people reacting to it in terms of which kind of jobs are they taking? So that is the study I'm really interested in. I would like to see your view and your opinion about that.
Well, interesting, Debo. I sat on a national federal agency robotic workforce, work committee. And yes, there are lots of impacts of technology that we don't understand yet.
Yeah.
Like what you're talking about as far as what they do in workforce deployment. You can find studies that support that it's a positive thing, and you can find studies that support it's a negative thing. I personally, most of the time, if I get a robot when I call a healthcare provider or a business, I get frustrated and hang up. However, there was one study that actually used robotics and generative AI, natural language processing, to actually respond to healthcare requests. And in that study, they found that the ChatGPT actually did a better job than the providers that were doing it. So, there's pros and cons to it. And this is why I'm going to keep saying that this is a 360 issue, right? Because we also have to help our community members make these adjustments as well, whether it's generative AI, whether it's robotics, whether it's the use of Alexa. I know she's going to turn on now, because it is a 360 issue. We can't just do research without helping our communities understand it and adjust to it and shift with it, because it's not going to go away.
Yeah.
So I'm glad you brought this up, because that is part of my 360 approach or perspective.
Thank you.
I saw someone else's hand. I don't see it now. I guess we answered whoever raised their hand. I was looking at the as Mark was scrolling, I was looking at some of the things, and one of the comments, in fact, it's up right now, about alcohol being part of a social determinant of health. And one of the things that we are doing here at NIH is we're really trying to define what is the social determinant of health. And behaviors are not social determinants of health. So that is one clear distinction that we can make. I thought I saw somebody's hand or something go up. Anybody?
Yes, hello, that was me. I was trying to figure out how to
How to
get my video.
There you go.
Yes, thank you so much for wanting to hear my input. The research, I'm LT Montgomery. I am very new to research, very new investigator. We are very interested in, I'm so glad that you said something, Deborah, about looking at social determinants of health more as assets. And so the research that we really want to focus on, to look at it going forward first, we would like to see brain images as a part of review of systems. We really want to be able to focus on how neuroplasticity, especially in middle-aged adults whom, most people may have said they're stuck in their ways, can't change, especially when it comes to chronic disorders such as substance use, diabetes, obesity, depression, and anxiety. We would like to be able to look at the actual brain and how it relates to those disorders. And then in the future, like we said, we want to be able to have physicians, as part of the review of systems, have a picture of that patient's brain, and then take a look from there and be able to kind of focus on the changes that need to take place in that patient's life. Thank you for listening.
That's great. Welcome to a very complicated research topic as a new investigator. Congratulations. One of the things that I would note is one of the slides that Luca presented at the very end, and it was on telomere length. We do know that the stressors that occur because of the social determinants of health in childhood, like especially adverse childhood events, racism, discrimination, those kinds of life stressors actually do impact our biologies, our brain, and we don't understand that. So I'm glad that you're researching it to understand what that means over the life course and the onset of disease. So as a new investigator, go for it.
Thank you so much. Thank you.
Ollie put a question in the chat. Yes. In fact, we have the slide that Luca presented, I think, has a reference link about the telomere length.
I didn't present that slide, but I do have it, and I'm happy to paste the link in the chat.
Yeah, he'll put Ollie, he'll put the reference to the article. There's several articles on this, so don't think it's just one. Anyone else? Just even from those of you who spoke, there are many complicated issues. And I'm very happy that you all are involved in this, methodology or approach using data science approaches, because as health disparities research, it is most complicated. And I think that's why it's been very difficult to really make an impact in disparities, because the interplay of many of the things that cause health inequities that result in biological changes actually are very hard to measure, hard to track, hard to keep, hard to understand. And that's why we need to use this methodology and create this paradigm shift to actually be able to understand these in a much more complicated way, where we have done lots of research in health disparities with single factors. And now we need to really look at these multi-factors and their not only interactions, but their synergy in causing health disparities and early health, poor health outcomes.
Can Luca repeat how you can, when you get a database, how you go to know what variables are in there? How do you, I didn't get it out.
You mean from our workspace?
From the workspace.
Yes, yes.
Well, actually, I mean, the easiest way is to actually download the data. That's pretty easy. You can do that if you want, and you can explore it on your computer.
Yeah, to see what's
Or,
in there.
Yes, so you can do that. That's the easiest way. Or you can, use one of our notebooks to see the instructions on how to access the data. Then you can easily import it, right? And, build a data table and,
But Luca, she doesn't want to build that. She wants to view the data set first. So I think the way that you do that is you go to the shared data set. You can click on the data set itself. And there should be also a tab for a data dictionary. And that will give you what is there. And if Luca can bring that slide back up. Luca?
Sure,
Data?
of course.
Because I think that's going to be important for a lot of people. So thank you for asking the question, Jane. Because sometimes if people don't understand, I think it's better that we know so we can help you.
Right.
That's the whole purpose of this, of Think-a-Thons, is to help you through what you don't understand.
Right. And then once you get that and you want to merge it with another data set that you see, you can merge to get what exactly you want to. So
I don't know if you can do it, Luca, with this view, or do you have to log in? Do you have to, are you still logged in?
I am, but I'm happy to.
Can
to
you do
help
it
people.
in here?
I'm happy to help people register. Yes, sure. I can just show it.
Okay.
It's gonna-
Go ahead and tell her how to do the. Okay, this is the actual workspace.
okay.
So so this is what you saw a screenshot of. And so this, well, he can just talk you through. So let's just do this graduation date one, Luca.
Sure. So if you're interested in this data set, for example, you see that there are many columns here with information on the size, the category, the year. So you can select the data for the year that you're interested in.
So hold on just a minute, Luca. So notice that there is data for almost 10 years. So in one of the things that we really wanted to do on this is to be sure that you had longitudinal information as well, because that sometimes is helpful.
Yep.
And then you see that the next two columns, this one is named data, and then the next one is data dictionary. And these are links that you can click to download the data. So to download the data set, you would click here. And to download the data dictionary, you would click on this link here.
Okay.
It's as easy as that. And there are many other ways, but this is the simplest.
Okay. So if you see something here and you want to merge it with another data set, what do you need to do once you see data set you like and you want to merge it with another one, which has the other variables you're interested in?
You mean if you can download multiple data sets?
Right.
Yeah, sure, you can do that, of course. Well, I mean, you can feel free to explore here. There are many categories, and you can actually look for, keywords or, tags. And let's say, for example, you're interested in, I don't know, economic stability. Or
And two, let's say I'm
Any-
interested in trying to look at maybe health behavior with the educational stuff. And
Exactly.
so I want to merge two data set to pull up the variable that are of interest.
Exactly. And
So
it's-
right now, you can take any one of these data sets and download it. You can
Okay.
download it onto your computer because we don't restrict that. Or you can download it into a Terra workspace.
Okay.
Either one works because we want to make this as easy and accessible to everyone.
Right.
Right now, the tool is not on here that actually merges the data sets. We won't release that until the fall,
Okay. Okay.
but you can download the two and do it the old way. But I will be talking to the contractor about us being able to use that tool during the research group so that we can potentially pilot test it and actually use the tool where we can combine data sets.
Okay. Thank you.
Of course.
So we have to use our Gmail. If I want to get into the Terra, do I need to use the Gmail? How do I log in to have access to?
So to get access, you go to the NIMHD webpage,
Okay.
the ScHARe webpage.
Or actually, even here, it's easier.
There's
Okay.
there's the links. Although I keep telling Luca, you put these little QVRs up, but you have to
I
do them on
know.
your phone, not your
It's like
computer.
register. So that's the registration.
Let me paste it in the chat.
But-
Let's do
So
that.
that's the one you want to register to with a Gmail.
Yes, you have to
Yes,
have
you
a
do need a
Gmail
Gmail.
account. For some of us that work like in government, our Gmail accounts are
Mhm.
work accounts are Gmail accounts too. So they've put it in the chat.
Okay.
So the links are there. And then you just follow the process to register. And when you register, Luca will approve it, and then you can access the data. And by the way, it's going to ask you to set up an account, but
Right.
you can kind of skip that part and just view. You don't have to. I mean, even if you set up an account, you're not going to be charged anything to view. You're only charged when you're doing computational work. And I can assure you that we have done everything possible to keep the computational costs low.
Right.
And if you're a first-time user to the computational part, you also get $300 credit from Google.
Oh.
Free.
Mhm.
It's $300 free dollars. It's a bonus when you sign up.
And actually, when you click on that link, what happens is, it brings you to this page. And here is where you can register. So you just have to input your name, role, affiliation, your Google email address. And there are a couple of optional questions. And that's it. You click submit. And then your information, gets to me. And then I will take care of registering it. So it's pretty easy. I stop sharing.
Okay. Thank you.
Sure.
And one of the things that I will stress is that our posted Think-a-Thons, if you get stuck on something on Terra, look at the title and go to the webpage and download or watch the video, or even look at the slides, because the instructions are in the slides, and it'll tell you how to do each step of it, even without ever having participated.
Okay.
And Temperance, I love the message that you put in.
Yeah.
So thank you very much.
Thank you. That makes us so happy.
You made our day, because this is exactly why we're doing things. And especially as an undergrad, this is where we want to capture people like you, so that you have an interest in this, you start to love it, and then you stay with us.
And mentors need to be here too, so they can help their students.
Well, Jane, I actually really talk about this as a generational exchange,
Right.
because young students like Temperance, who is a computer science major, will bring to the table her analytic math skills from the computer.
Exactly.
And someone like you that has health disparities research, you guys are going to work together and create a great project, and you're going to teach each other.
Exactly.
And that's why I call this a generational exchange across
Right.
across career levels and disciplines.
Right. That's why the folks I'm working from Georgetown, they are in informatics.
Yeah.
And I'm coming from a social science background.
Yep. And you're teaching each other.
Right.
And that's how we'll make this work.
True.
Right.
Yes. Thank you
Um,
much. Very appreciate
As we're coming to the close, I'm going to ask Mark to put up our final evaluation survey. If you can please fill that out before you leave. And thank you all for the suggestions. Of course, we're going to save it. As item, we'll save the chat information for those of you who put your ideas in chat. So we make sure we save those as well. And I really appreciate all of you coming and joining us, and we look forward to next month. Luca, do you have any last comments?
Thank you so much for coming. I really appreciated that. And we look forward to seeing as many of you as possible next month for the Think-a-Thons.
Please fill out the survey. And even though we're going to close out of the Think-a-Thon time, the survey will stay open so that you can respond, you can fill it out. Okay. Thank you all.
Perfect. Thank you all.